Back in video 23, we did a problem where we had a 5-volt power supply, a resistor, an LED, and ground. We discovered that the value of the resistor, in order to limit the current through the LED to no more than 20 milliamps, was 250 ohms. Now let's imagine, instead of using a power supply that's 5 volts steady on all the time, you instead want to use the Arduino as the thing that's going to actually power this LED. Well, I'm going to introduce a new schematic symbol that we haven't seen. And I make it really simple. I draw the big letter A with a box around it, and I say, well, that's an Arduino. Now, is this an Arduino in all contexts? Absolutely not. This is an Arduino in the context of an environment where people who know that that symbol means Arduino. It's not universal, but in a certain bounded system, this is a perfectly understandable thing. If you want to share a schematic with the world or other people in other places, you should label this something more like Arduino Uno R3 and specify exactly what that thing is, and then they'll know. I'm going to mark a few pins on the Arduino. There's a 5-volt pin I'm going to mark and a ground. And you will note that I'm not exactly mimicking, this is an actual Arduino, I'm not exactly, there is no 5-volt pin in the top center, there is no ground in the bottom center. However, it's very common for all sorts of electronics to mark 5 volts at, or the power in at the top, the ground or the sort of 0 volts at the bottom. It's just a standard way to do it. And on this Arduino, I'm just going to mark other pins as needed. So let's say I want to plug an LED into the Arduino. Where do I want to plug it in? Well, I have a lot of choice. I can use any of these digital pins will be fine. Remember, we said maybe don't use 0 and 1 if you have the possibility not to. So how about pin 8? No special reason. I'm going to draw the number 8 and a little leg coming out. So again, the question is, we're going to power an LED with the Arduino. How are we going to do it? Well, it's actually pretty straightforward. Coming out of pin 8 basically is going to be like this 5V. Instead, we can actually just, where my finger is, you can imagine that being the 8. So it's going to be 8, then a 250 ohm resistor, then an LED, and then what's going to be at the far side? Ground. The ground I'm going to show with that symbol. And this ground, I'm going to also attach it to that symbol just to be very explicit and say, whenever I draw one of these, I'm talking about being connected to one of these. So you can imagine a sort of dotted line connection here, but we need not draw that dotted line connection. The whole point of using the ground symbol is to avoid needing to draw those things that are not really necessary. So this is the circuit for powering an LED with pin 8 of the Arduino. In this case, pin 8 can be turned on and off programmatically. We can write software to turn it on and off. In this case, 5V, if that's like a battery or a power supply, like you can't write software to turn a battery on and off. So the advantage of this is that pin 8, we can tell it what to do. We can blink that light, we can do whatever. Turn it on when something else happens. So now there's another question. Okay, fine, you've drawn the drawing and it makes reasonable sense. How do you actually go about building it? Well, we're going to actually step into the world of actual electronics now, as opposed to just the on-the-paper theoretical electronics. Here is an Arduino. And the next thing I'm going to show you is not an Arduino, it's this puppy. This is called a solderless breadboard. I'll just move down here. And I'll label it solderless breadboard. Solder, S-O-L-D-E-R, is a soft metal with a low melting point, which is used in making electrical connections between things. The solderless breadboard will allow us to make electrical connections by plugging wires in without needing to solder. The way it works is the following. It's got these little rows here that go across. So row 1A, get a little closer. This is pin 1A. It's connected to 1B. It's connected to 1C. It's connected to 1D. It's connected to 1E. All of these underneath the board are connected to each other. So I'm going to draw a little row there showing that. Now they're not connected to these ones across the way. F, G, H, I, and J, they are all connected to each other in row 1, but they're not connected to this one over on the left. So that's another little row over there on the right. Row 2 is not connected at all to row 1. So it looks kind of like that. Similarly, row 2 over here is not connected to this row 2, and it's not connected to this row 1 over here. So all those things are connected. In practice, this means if I have one wire, let's say this red wire, and I want to connect it to this green wire, I can plug these two things in like that. Now they are connected. Why? Because they're in the same row. And all of row 1, as the drawing shows there, I can label it row 1, row 2. They're all connected to each other. Are they connected to each other right now? No, because even though they're in the same column, there are no connections running up and down the columns. Are they connected to each other now? No, because they don't run across. And finally, what if I want to connect 3 things together? Well, I could just connect 3 things all into the same row, like that. And now they're all connected because I can connect up to 5 things in that little row there. Now, there are these other things running up and down the left side. These are called the power rails, and they are separate. They are physically separate from the board. If you're not sure of that, you can separate your breadboard, and there's no electrical connection there. So the power rails are built differently than the middle part of the board. So I'm just going to draw a few more of these. It's not especially neat, but I'm just trying to illustrate that it kind of just runs all the way down in that style. The power rail, this one is labeled minus, and that column, that entire column is connected to itself. So there's an entire column there that runs all the way top to bottom. Next to it is another column like this. They are called the power rails because the expectation is that you will plug in power, typically using a red wire, to one of those columns, the positive wire. You will plug in ground, like using a black wire is the typical color for that, into the other column. And now anywhere in this column, if you ever needed power, let's say with this green wire, I could just plug in right here, and then I would have power. Or I could plug in here and I'd have power. Any place I need it, I could plug in. Similarly, if I needed ground, I could plug in there, and now I've got ground, there, and now I've got ground, etc. The left power rails, they are definitely separable from the board. They are not connected to the right power rails, which are also separable. So those are different power rails. So now this drawing is a kind of schematic representation of the breadboard. But if you're ever really forgetting how the wiring actually works in there, there's a nice little trick, which is you can simply turn the breadboard over. And there's 2 layers of adhesive here. The first, if you peel it away, you'll see the sort of double-sided sticky tape. But I'm going to peel even the double-sided sticky tape and reveal the actual connections in the actual breadboard. Lo and behold, they look a whole lot like my schematic drawing of them. These are the little clips, the metal clips, that actually do the job of connecting. So when you stick a wire in from the front, what's happening in the back is it's actually being grabbed and held onto by that little clip. And you can see very clearly, based on the way the clips are actually physically arranged, how connections are made in the breadboard. In the next video, we're actually going to wire up this circuit with our newfound knowledge of the breadboard and do the practical work of actually making that connection.